We are on the page 54, section 12.1, sequences and series. We are going to learn the third thing in this class. It's called pattern recognition. Okay, so if you see this one, moon, sun, moon, star, and sun, moon, and star, right? Then what do you expect to see next one? Then you will see these patterns, right? So then you will kind of expect to see things like that if it follows the pattern. So same thing as in the heavenly bodies, all the, the stars, the planets, they run the same patterns around the sun, right? That's how we learn things and accumulate our knowledge this way. So if I said, if I, got married, got divorced, and got married again, and got divorced again, and then I got married again, what do you think I would do? Right? Next one, I may get a divorce, but I may not. But according to the patterns, it's more likely certain way will happen. So it will help us to recognize situations. That's how we learn and recognize the patterns, right? Then, so math, what do? We use numbers. So instead of that, we use numbers and we do add, subtract, and multiply, and divide, things like that to find a pattern. Okay? Then things we are going to learn is called sequences and series, is certain type of patterns to help us to learn from the math to see what will happen for the next number, for the next pattern. Okay? So, it's talking about patterns, right? Then we use the word sequence. What does that mean, sequence? It's a sequential event, things will happen, right? So we use number to help us to connect. So if I have items, certain items, right, on your paper. So if I have 1, 3, 5, 7, what do you think next one you will expect? How do you get that? It's all a number, right? You will add by 2, 1, 3, 5, 7. You will expect here will be 9. Okay, that will be first number, second number, and so on. And if I have 2, 5, 8, 11, what do you think the next number would be? So you kind of see how you get it from first number to second number. If third number follow the same thing, that would add 3. Are they all adding 3? Then we will do the same thing next one. So this one will be 14, right? If we have, say, 2, 4, 8, 16, what do you think? Next number? That will be 2, 4. If it's added 2, that will be 6. So it's not adding by 2, right? However, you will see, oh, this is double from the previous one, double, double. So you will be what? By multiplying 2, right? So next one will be what? 32. Is that right? So either by adding subtracting, multiplying, and dividing, but sometimes it's not. Okay? If I have a 1, 4, 9, 16, and what do you think next number would be? Right? You see, okay, I just try adding and multiplying. So this one would be what? Adding 3, adding 5, adding 7. It's not adding same number, right? But how about multiplying? Doesn't work. So, but you see the adding 3, 5, 7, the next one you probably would expect increase the same number. That would be 9, that would be 25, right? That's one way to look at the pattern. Another one, you can look at this way as well. But you may not see right away. So you say, oh, this is 1 square. This one would be what? 2 square. This one would be 3 square. Would that be right? That would be your, okay. It might be this pattern. So next one will be what? 5 square. You still end up same thing, 25. Okay, that's one way to look at it. And if we have this way, this one, say 1/2, 1/4, 1/8, 1/16. What do you think? Next one, 2, 4, 8, 6, like this. But it is the fraction, so that would be what? 1/32. That's how we look at it. Okay? Then we are going to specify them, identify them with different names, so we know how to call them out. All right? So these type of things we call it what? Sequence. And is what? A number of events, it follows certain patterns. Right? So for each event, you say this is the first event, second event, third event, and so on, right? And if the first one, those are the pointer to point which position we are in, then we call it location pointer, right? Then the sequence will be this way. The sequence, it will show actual, like this one, first number, second number, third number, fourth number, right? So those are events to identify when did they happen, like first day, second day, third day, right? The sequence is those numbers. Okay, we use number to learn the patterns. So the sequence we use what? Bunch numbers. We say first number A, we use A as a number. Then how do we show them? We use the subscript, right? So 1, 2, 3. So those just the symbols. Identify those numbers. Just like we recognize the symbols, then see how it will, to be predicted in the future is like this. Say, day 1, I have so many viruses. Day 2, day 3, day 4, then to the down the road, then say 15th day or 100th day, how many viruses I will have, right? If it follows certain patterns. So the number, the notation we use, symbols we use would be A1, A2, A3, right? So this one will be the first term, right? So this one will be your first term, right? this one will be your second term. Then n all the way, this one will be nth term. So you have many variables. You need to differentiate them. What do they mean? Okay? Just like those patterns, it means certain thing. So we just introduce the symbols first. Okay? So nth term, usually we will refer this one. You will get confused when we say, okay, the general term. Okay, means what? We use nth term. It means n can be 1 means the first term, 5 means fifth term. Okay, and the subscript, those 1, 2, 3, those things we call it what? Subscript, which is the index, the pointer to tell you which term we are talking about. Okay, so if I have a sequence like this, 2, 5, 8, 11, right? All those things will be your ith term. Then those things, we call them what? Values for each term. Okay? Then the first, second, and third, this one, we call them what? It's the index point to the positions and locations of the each terms. Okay, index day 1, day 2, day 3. Okay? We also can look at this way, right? So from 1, 2, 3, all those indexes, right? Indices, and point to the value, say 2, 5, 8, 11, things like that. Then you will look like just like your function, right? Function, okay? That's your domain, maps to your range values. So you can look at it as a function. So all the algebra we are talking about are functions. We can look at that way, one way or the other, okay? So if we write as function, f of 1 means what? Like here, okay? If I have, say, instead of 2, 5, 8, 11, I have 5, 10, 15, and so on. Then f1 would be what? 5, f2 would be what? 10, f3 would be what? 15. Then we use this symbol. Instead of function symbol, we use what? For the sequence symbol, okay? We use what? This A1, A2, A3, things like this, okay? For the sequences, we use such symbols. All right. So we might have what? 2 types of sequences. One is called infinite, okay, sequence. Another one is finite sequence. Okay, infinite, the concept of infinite is the base of calculus. It's very abstract, okay? But we start from here. And infinite sequence means what? You have from 1, 2, 3, 4, infinite numbers of the values, positions, right? finite sequence, we use this. We say 1, 2, still finite means it stopped somewhere, stopped by n. When we write ending number, n means particular number. Okay, can be 5, can be 10, right? And n is some number, but it will stop. Infinite sequence, it will not stop. Okay, so each number of the sequence, we call them what? A term of the sequence. Each one, A1, A2, A3. This is the first term, second term, third term. You have many, many terms. Okay, all the way to the nth term, that would be the finite sequence. Okay, so we start to introduce the concepts and vocabularies first, and talk about things we are using. Then we will use those symbols to identify things. Okay, then so we say find the four terms of the 12th term of the of each sequence. Find the first 4 terms and the 12th term of each sequence. It's on your page 55. So we want you to practice, see what kind of things in there. If we have a patterns, we have a pattern this way. Then n means what? It's general term. Can be 1, 2, 3, 4, right? So we want you to find the first 4 terms and the 12th term. Then how you are going to do that? Then you just plug in the index. First term means what? A1. A1 means n is 1. You plug in 2, 1 minus 1, right? A2 will be what? 2, 2 minus 1, right? A3 would be what? 2/3 minus 1 would be 7. 2/4 would be, A4 would be this, right? That's what I mean. Then how about 12th term? So that would be A12 to the 12 minus 1. Then you can put it into the calculator to find the numbers. Okay, so this pattern, general term, is telling you you will follow this pattern. So that would be, the sequence would be what? 1, 3, 7, 15, all the way if to the 12th term, that would be this number, right? That's what the symbol is telling you. Okay, if we tell you my pattern is this one, that means what? A1 is -1 to the 1 power, that would be -1, right? A2 would be -1 times twice, would be positive. A3 would be 3 times, go back to negative. A4 would be what? 4th time, come back to positive again, right? And so on. What do you think? A12 then would be 12th power, would be positive. So this pattern is telling you start from negative. -1, 1, -1, 1. Then you flip the signs from positive, negative, negative, positive, and the patterns goes with that, right? And if we have this one, if I have, say, I'm thinking don't use F. So if I use, say, H, H doesn't, it's not good. So if I just use AN, all right, -1 N, all right, N times 5. If I have this pattern, what does it tell me? This one means what? 1, that would be -5. 2 would be +5, right? So your pattern will be negative, positive, and multiplied by 5. The patterns become this. If just 1, -1, you will have -1, +1, -1, +1, right? Look the C, if we have Cn equals -1, n plus 1 instead of n. So what do we have? A1 equals what? -1. So your n is what? 1 at this time. 1 plus 1 is what? 2. That would be 1, right? A2 would be what? -1 to the third. Instead of second power, you have one more power. It's -1 now. So A3 would be -1 to the fourth power. That would be 1. A4 would be -1 to the fifth power would be what? -1, right? Then, what do you think? A12 would become 13. That would be -1. Then, the pattern would be what? Start from positive. So it would be 1, -1, 1, -1, and so on. It's different from here, right? This one started from -1, 1, -1, 1. So if you increase your power by one more time, you flip the sign another way. Start from positive, negative, positive, negative. This one is negative, positive, negative, positive. Okay? So we want you to connect your thinking, flip, this way and that way, move forward, certain pattern, okay, to help you to think this way and connect scientific way as such. Okay, so if we have this, then what do you think? D1 will be what? Will be 1 minus 5, 1 plus 1. You just plug in, right? That would be absolute 4. Then that would be 4 divided by 2 is 2. D2 would be what? 2 minus 5, 2 plus 1. That would be what? It was -4. This one is what? -3 and 3. That would be 1, right? D3 would be what? 3 minus 5. You just plug in. 3 plus 1. So that would be 2 fourths would be 1/2. Is that right? D4 would be 4 minus 5, 4 plus 1. That would be -1, 1/5. So all you need is just plug in your symbol as it says, right? And if D12, then that would be what? 12 minus 5, 12 plus 1. That would be what? 7, 13. That's all you need to do. Just plug in. Okay? So we want you to connect your thinking from the pointers, you know, first day, second day, third day, then connect to how many viruses, you know, say viruses cases that would be. So you write a sequence, a sequential event, what happened, okay, and presented by numbers. Okay, so if we give you a pattern, then you should be able to find the numbers. Then if we give you a numbers, then we ask you to find the patterns. What does that mean? That means we want you to find the nth term. Like this one, first, second, third, fourth, fifth term, right? You continue. But if we want to find the 100th term, you cannot write 100th time. That will take you forever. So we want to find the patterns like this. Then we just plug in the index like 12th one. Then you find your answer right away. So we find the general term, the general patterns, so we can predict the 100th term, what will happen, right? So like this one, what do you think? How do we make it? So this one each is by doing what? Add or subtract, multiply, divide. So 4 add 4. Add 4 will work. Will that work? It will work. Right? Now the multiply doesn't work. So if each time you add 4, then your pattern, because each time you add 4, then first one would be what? First term would be 4. Second term times 2 is 8. Times 3 is 12. So if each time is 4 more, then your pattern will be just 4n. Okay? Because each time n increase by 1, you increase by 4, actually, for the numbers, right? If you have this one, 6, 10, 14, 18, so what's the general pattern, general term? Take a look. So it's what? By adding 4, right? Still, then we say add 4, I should have a 4n, right? However, it doesn't work because n is 1, it's supposed to be 4, but now it's 6. What can you do? You have to match the first term to the first term so you can check. You have to add 2, then that will work. Okay, right now we are only guessing. Right? We are only guessing. Then later on, we can find the formulas to fit in your patterns. Okay? Just for now, we do the observations. So let's see. If we have 3, 8, 13, 18, 23, so what do you think the general pattern will be? Okay, then we say, okay, every time you add, you just do like add 4, 4n. But this time it's add 5. Is that right? Add 5. So we say by adding, I should have what? 5n. Right? Then to guess, we are just guessing, right? So 5n would be what? 5, 10, 15, right? 20, and so on. It will not work for the first term. For the first one, from here, 5n is 5. How can you make a 3? If you minus 2, that will work, right? Then second term would be 10 minus 2. Third term would be 15 minus 2. So it will fit. Okay? So you just plug back in 1, 2, 3, 4. Then you can see those numbers showed up. If the next one, 2, 4, 8, 16, 32. what's the pattern? It's not adding 2. That's 8, 4, add 8. So you cannot add them. How about multiplying? So for us, we just learn the basic patterns, mainly dominated by adding and multiplying. Okay, so we learn those patterns, simpler patterns first. If we multiply by 2, what do? AN is, we do this way. Okay, so we do 2 to the nth power. If multiplying means it grows exponentially, right? So then the variable will be on the exponential position. Okay, so we check. N is 1, that's 2. N is 2, second term is 4. N is 3, third term is 8. 4, fourth term would be 16. That's how we do. If we are multiplying by a number, we do what? We should do, this is our base, because multiplied by, then N is your index. Okay? Adding, you just multiply the numbers, increment number by the index. If it's multiplying, you have to use that, things multiplied, 2 as a base, then raise to the power as your index position. That's what he's saying. Okay, next one. If we have this E, -3, -9, -27, -81, what's our pattern? Take a look. So the AN, each one is multiplied by what? 3, right? So we say it's exponential growth by 3, right? Power of 3. So your base is 3, then your power is N. However, our N is whole number, right? The positive number, 1, 2, 3, 4. So if it's 1, it's a 3, not a negative. But all the numbers are negative. All you need to do is what? Add a negative in front of it. That will work. Right? So let's take a look some more. Okay, so those are just simple patterns, straightforward, from the adding same number or multiplied by a certain number, E. Okay, let's see. Next number we have is this one, F. Okay, pattern 2, 4, -4, 8, -6, and 32, and so on. Okay, so what do we have? Are we multiplying or adding numbers? We are multiplying, right? Multiplying by -2. -2 will be next number. So the patterns will be what? Your base is -2. Is that right? Then to the nth power. You can do that, right? And however, you have to check. It's multiplied by -2, but N is 1, that would be -2. N is 2, it's a +4. So the difference is this one. You have to use negative in front of it to match with the patterns. Is that right? N is 1. Yes, that would be positive N plus your negative here, right? N is 2, negative. This is a positive and negative. That's correct. right? Okay, let's take a look at next one. If G is -4, 16, -64, 256, and so on. Okay, and let's see. We are multiplying by a number which is what? -4. Right? Then we say, how do we write our patterns? So your AN would be to the nth power, the multiplied by -4. Will that work? -4, one power is -4, second power is positive 16, right? But this one is opposite, then the sign, you have to add a negative number there. Okay, next one, if we have this, what do you think? Then you know the patterns, the pattern has 7 on the top, right? Then what happened to the bottom? We got it by demultiplying or by adding from here to here, multiply by 5, right? Then we say multiplying, you use this style. Then you use this base, then you put it in here. Will that work? Then it's 1, that would be this. Then it's 2, will be your second term. Would that fit? Looks like it. So it works that way. Okay? Let's take a look at the next part. Okay, we are on the page 55. This one is not on your paper, okay, but it's on the homework, this part. So we need to cover this. Another types of patterns you might encounter later on. All right, so it's called the different things. Let me see what's the name we'll use. Okay, it's called this one, use factorial notation. It's another notation you will encounter later on for all math, right? Calculus, pre-cal, or stats. Okay, factorial notation is this sign, exclamation mark, you are going to use. It has a special meaning in math. Okay, let's see what do we mean by that. Okay, so it's saying something called factorial. Okay, so we say the factorial of n is this way. We use n, then we put the exclamation mark there. Okay, then n is a positive number, and this symbol means this way, n times n minus 1, n minus 2, all the way to, say, times 3, times 2, times 1, okay? N is a positive number. N is a positive number, okay? Then we also give you, if that means, what does that mean? Let's see some numbers first. So you know what we are talking about. All right. So we say, if you see this one, what do we expect you to do? 1 factorial. Okay? It means you multiply all the numbers smaller than it. So this one will be just 1, right? Because end up with 1. If 2 factorial means what? You start from 2, then you reduce 1 until you hit 1. So that would be 2. 3 factorial means what? 3 times 2 times 1. That would be 6. Okay? 4 factorial would be what? 4 times 3 times 2 times 1. You will end up, you just multiply them out, right? 5 factorial would be what? 5 from 5, then reduce 1 until you hit 1. 5, 4, 3, 2, 1. That will be 120, right? So if 19 factorial would be what? It means you need to times the 19 to 18, 17, all the way to 3, 2, 1. Then you can find the answer this way. All right, that's the simple mean. Okay, so then we have another one. It's given to you. If you have 0 factorial, it's 1. Okay, this one is given for a reason. Okay, so because it end up with 1, you stop at 1. Okay, so you see some examples that way. Then if we say write the first 5 terms of the sequence. Okay, if the general term, then whose general term is this way: an equals 1 over n factorial. So we have a patterns, general pattern is this one, 1 over n factorial. Then write the first 5 terms. What do you need to do? You need to do A1, A2, A3, A4, A5, right? A1 means what? N is 1. You plug in 1 to 1 factorial. 1 to 1 is 1. A2 would be 1 over 2 factorial. That would be what? 2 factorial is 2. That would be your answer, right? A3 means what? According to the pattern, we have 3 to the factorial, then 3 factorial is 6, so that would be 1 6, right? A4 would be 1 over 4 factorial. 4 factorial would be 24, okay? So for each term, that would be your value. So 1 to the 5 factorial, 5 factorial is 120. So that would be the value for the 5th term if the pattern is this way. Okay, so we are talking about new thing for you called factorial notation. Okay, if we have this one, write the first 5 terms. If the patterns is this way, an equals n plus 1 factorial over n minus 1 factorial, then we want you to find the first 5 terms. That means you need to find A1, A2, A3, A4, A5, right? Then A1 first term means what? N is 1. You match the index, right? That will be 1 plus 1 factorial, 1 minus 1 factorial. Is that right? So that would be 2 factorial, 0 factorial. Then 2 factorial is 2, 0 factorial is 1. So you will have a 2. Is that right? Then second term will be what? You plug in, n is 2. So that will be 2 plus 1 factorial, 2 minus 1 factorial. So that would be 3 factorial, 1 factorial. 3 factorial actually is 3 times 2 times 1. 1 factorial is 1. So that would be 6, right? You can just spell it out and using what? The factorial notation and change them to write it out. A3 means what? N is 3. So you plug in 3 plus 1 factorial, 3 minus 1 factorial. That would be what? 4 factorial divided by 2 factorial, right? So you don't have to find the number if you spell it out. 4 factorial means this, right? 2 factorial means this. Then you can cancel out. You got 12. Following me? Straightforward, right? So find each term as long as you know what do we mean by the sequence and the patterns, right? So this one, n is 4. You plug in 4 plus 1 factorial, 4 minus 1 factorial. That would be 5 factorial divided by 3 factorial. That's 5, 4, 3, 2, 1, 3, 2, 1. Those cancel out. So your answer is 20. Right? Straightforward, right? So A5 would be 5 plus 1 factorial, 5 minus 1 factorial. That would be 6 factorial over 4 factorial. That would be what? 6, 5, 4, 3, 2, 1. 4, 3, 2, 1. Cancel out. So what do we have? 30. Is that right? So think about it. What are we learning? We said the patterns, pattern recognition. Then we use the sequences right now. Okay? Then we learn all the symbols, each term, the index and the value. Then we want to find the sequence, means we want to find the values for each term. So first term, second term, third term, fourth term, and so on. So that's what we are doing. Okay? We are doing the pattern recognition, then find each term. So we just learned something called sequences, right? Those are sequential events follow a certain pattern, okay? Then next thing we are going to learn is something called series, all right? So a series actually is a singular, not a plural, okay? A series is the sum of the terms of a sequence. So individual event, right? Day 1, day 2, day 3, how many various cases we might have, right? So it's a sequence of event. The series means what? The sum means total. When you add up all the total cases we might have, then we call it what? A series. Okay? So a series, we might have what? Infinite or finite, either finite or infinite. Because you have a finite sequence, you can have an infinite sequence. So same thing for the series. If you add together infinite events, then that will be infinite series or finite series. Okay, so if you look at the example, if I have a sequence like this, by, let's see, by adding 6 without work, okay, by adding the 6, right? So the general pattern, as we talked about earlier for sequence, then you will write what? Each item, each term will be nth term, right? That will be by adding 6. That will be 6n, right? By adding. But to fit in the first one, you have to minus 2 because 6 times 1, 6 minus 2 is 4. If the second term will be 2 times 6, 12. 12 minus 2 is 10. Okay? We are still guessing. Okay, later on we will find the formula for it, but for now, that's what we do. Then let's talk about finite series. So for the finite one, it means what? If I add 4 of them together, I will do 4 plus 10 plus 16 plus 22. Then I find the answer, right? That would be the result. You add them together, becomes what? Total various cases, right? Situation like this. If it's infinite series, what are we talking about? We would do this way. 4 times 10 times 16 times 22. Then we have to keep going to keep adding. So we just use this symbol, 3 dots. All right? So we use this to represent the idea for the infinite series, right? For this one, we can find the answer, right? Then for this one, do we have an answer? You just keep adding, right? So it doesn't have an answer. Actually, it doesn't exist. Right? Because you don't have a fixed number to find. That's what happened. Okay? Right now, we are introducing the idea what kind of things call a series. Right? Then we have a particular symbol to use to represent the idea. Is this one. It's called sigma. Okay? So we use this symbol, sigma symbol. Then we have things like this. If I write a 2i plus 1, what does that mean? Then I write I equals 1 and 4. What does that mean? Okay, this one is called sigma symbol. It means what? Sum, S, right? Greek S symbol, sigma, means the sum. And what else we have? Okay, we have I here. I means what? Like your n here. Okay, it's your index. That one is index of summation. All right, then 1 means what? Starting point, lower index. Top one means what? Upper index. Okay, it means you will run, the I will be 1 to 4, means 1, 2, 3, 4. So if you plug in I is 1, what do you have? Right? I is 1 will be 2 times 1 plus 1, right? That will be your first term. Then second term, I is what? 2. That will be 2 times 2 plus 1, right? Third term will be what? 2 times 3 plus 1. Fourth term up to 4, right? Plus 2 times 4 plus 1. Then actual value is 3 plus 5 plus 7 plus 9. Actually, it's 24. It means this number, okay? But this summation sigma notation, it means how you are going to operate on. Then it tells you it runs from what? First item, first term, all the way to the fourth term, upper bound. Okay? So that's the notation mean. If we ask you, look some example, all right? If we ask you to evaluate this one, then what do we expect you to do? Find the summation, find this series, okay? K is running from 2 to 5. So for the first item means what? How many items you have? You need to count your finger. From 2 to 5. How many terms you have? 2, 3, 4, 5. 4 terms. Up to 5, you don't have one first term. So 5 minus 1. You have 4 terms. Then you have to add them together, right? So when K is 1, you plug in 2, right? Oh, K is 2, to start from 2. 2 times 2 is 4. 4 minus 3 is what? 1, 1/5, right? So second term, K is 3. 2 times 3, 6 minus 3 is what? 3, right? Then next term, 2 times 4, 8. 8 minus 3, 5. 5/5. Then next term, K is 5. 5 times 2 is 10. It's a 7/5. So this notation means this. Then the result is 1 plus 3 plus 5 plus 7, 16. So your answer should be this one. Okay? Summation, sigma notation means what? The sum. Then you have to sum it, right? Add all of them together to find the sum. Okay, then this one, for this pattern, how do you find the series? Sum it, right? So how many terms you have? From 2 to 4, up to 4, except the first one. So 2, 3, 4. So you have 2, 3, 4. So you have 3 terms. So you plug in individually. So when n is 2, what do you have? Negative 1 to the 2 power 5 times what? 2 to the 2, right? Second term, n is 3. That would be negative 1 to the 3, 5 times 2 to the 3 power, right? Next term, n is 4. You have negative 1, 4th power, 5 times 2 to the 4th. Then you just have to add them up. 4, 20, positive. That one is negative. 8, 5, 40, plus, right, 16, 80, positive 80. So your answer should be what? 60. Okay? So if we give you a summation notation, sigma, then you need to add them up, find the answer, right? If we have this one. We give you a sequence, right? Sequence means what? 6, 11, 16, 21, 26. Right now is, but when we add them up, that means we have to find the series. Then we want you to present with what? Sigma notation, how you are going to do it. Right? How many terms we have? 5. So usually we just do n equals 1 to 5, right? 5 terms. Then you will write a general pattern here. Then each term will be those numbers. Then sigma, you will add them up, right? Right now we are still guessing the patterns. So, but for this one, we know it's by what? Adding 5, right? So for adding 5, we say the pattern should be what? It's 5, right? N, right? Adding 5 is 5 times n. However, we have to match the first one. First one is plus 1, right? So the pattern means n is 1, that would be 6. N is 2, that would be 11. N is 3, that would be 16. So what you would do is you will write this pattern general term here. So you write this way, 5n plus 1. Okay, you need a parenthesis there. So that means you write a general term behind your sigma notation. General means general. If you plug in n is 1, that would be first term. N is 2, that would be second term. Some of you will get super confused with all the index and with the term, with the terminologies. Then which one is general term? What do they mean? Which one is the index? You need to differentiate that. You need to do homework to practice to connect. Okay? That's how we write a general term. However, on your paper, we wrote this one. Okay? E equals, this way, we wrote k is 1 to which number? So you put a 5 there, right? But since we used the index k instead of n, so your answer should be what? 5k plus 1. Okay? You can write it this way or this way. Either way is fine. But if I give you the k, then you need to use k. Right? Look at the second one. 3 plus 9 plus 27 plus 81. So, do we have a finite series, right? So, sigma n is 1 to some number. How many numbers we have? 4, right? Then we need to find a general term for it. So, for this number, for this sequence, are we multiplying or adding? We multiply by 3, right? So when we multiply by 3, then we say you need to use 3 as a base by nth power. Then we check. 1 is 3, 2 is 9. Correct. Okay? So we will put a 3n general term behind the sigma symbol. Then if we give you this one, we give you this already. We say k is ask you to fill in all this. So your k is what? From 1 to 4. Then the general term will be 3 to the k's power. Right? Next one, 7 plus 14 plus 28, 56 plus 112. So our sequence is 7, 14, 21, 28, 56, 112, right? We want to write a sigma notation. If I just use n, would be 1 to how many terms? 1, 2, 3, 4, 5, right? Then I'm going to write the patterns. General pattern behind it. So what do we have? We have add or multiply. It looks like what? Multiplied by 2. Right? Is that right? Then for multiplying, we say you write it this way. You write 2 base with what? N, right? Then we'll have to fit in the first one. If 2 to the nth power, that would be what? 2, 4, 8, 16, and on, right? It's not 7, 14, all that. So how do you make 2 become 7? You have to multiply 7 halves, right? 7 halves times 2, 7. 7 halves times 4, 14. 7 halves times 8, 28. That will work, right? So we will have what? 7 halves times 2 to the nth power. That's how we write. However, we give you this one, sigma. Then on your paper, let me see, we have what? We use m, right? So it will give you m, then you have to fit in. That would be m equals 1 to 5. How do you write inside, right? That would be 7 halves times 2 to the what power? No longer n. You need to use m power. Got it? Right? That's how you write the series with sigma notation. Okay? You do need to practice, and so it can sink in and be connected. Look, next one. 20 plus 4 plus 4 fifths plus 4 25th plus 4 125. Then we ask you to write a sigma with what? They want you to write as k equals some number to square and write your pattern here. Okay? So our sequence is this one. It's by multiplying or by adding. Let's see. It's by multiplying. Actually, multiply by what? 1/5. Is that right? Yes. Okay. If multiplying, we will write the patterns as this. Will be 1/5 to the nth power, right? Multiplied by 1/5. But we have to fit in the first one. If n is 1, it's 1/5. We want to make it 20. That means you have to multiply by extra 100. All right? 1/5 times 100 is 20. Then second one, then second power will be 1/25. Then times 100, that would be 4. Right? So that's our pattern. Then let's see, how can we write an answer for it? We want to use k. K is how many terms? 1 to 5. Then what do you write inside? You will write it this way. Okay? You will write 100 times what? 1/5 to the k power. Right? That's how you write a summation notation. Let's look at the next one. a plus 3 plus negative 2 plus negative 7 plus negative 12 plus negative 17. We want you to write the sigma with notation with k, right? Then write your answer patterns in here. So k is how many terms? From 1 to 6 of them, right? Then for this pattern, so are we adding or multiplying? Let's see, looks like adding, right? So what do we have? Not add 5, actually subtract 5, right? It's the same thing as adding negative 5. So if it's addition, we need to use this pattern, right? We say if multiplied by negative, you will write what? Negative 5n. Okay? But you have to fit in first one. First one, negative 5, and it's negative 5. To make 18, you have to make 8, we have to what? Plus 13, right? Then second term would be would be 2, negative 10 plus 13, that would be 3. So you need to write the negative 5n for negative 5, multiplying by negative 5. Then plus 13 to fit in the first number. So how do we write the sigma notation for this one? That would be negative 5k plus 13. That's general pattern for k from 1 to 6. Right? Got some idea? Okay. So, what do you think? Why we have to learn this? Besides, it is a pattern, right? And this is the basic concept, how we build our calculus. By then you will find out, okay? So we start from here. Now, let's look some apps. Just a simple one. Okay, how we apply the concepts. So on your page 56, on the bottom, first one, it says the population size of a culture of bacteria triples every hour, such that its size is modeled by the sequence of n equals 50 times 3 to the n minus 1. Okay, where n is the number of bacteria present at the time of the hour, just beginning by the hour. Okay, find the size of the culture at the beginning of the first hour. So beginning the first hour, and we have second one is the 4th hour, then third one is the 12th hour. So what do we need to do? All we need to do is what? First hour means what? N is 1. So you do A1 equals 50 times 3, 1 minus 1, that's 0 power is 1, so that would be 50. Right? Okay, then 4th hour, N is 4, then we'll find A4, that would be 53 times, just plug in 4 minus 1, 3 to 3, 27 times. So that's how many bacteria we have. 12th hour, N is 12, right? So we'll find is that what? 20th hour, not the 12th. 20th. So N is 20. So we find the 20. So 53 to the 20 minus 1. Then it's so many. Then you can just plug into the calculator to do that. Okay? That's how we see the sequence of event for each event, which day, which hour, then how many there. Okay? Look your next page, 57. Second example, it says, a small theater has 10 rows with 12 seats in the first row. Okay, 12 seats in the first row. Total, they have what? 10 rows. And 15 in the second row, 18 seats in the third row. Okay, then find the number of seats in the 8th row. He asks you, okay? That's write the sequence, see how it looks like. So first one is 12, next one 15, next one 18. What do you think? What kind of pattern is that? By adding or by multiplying? By adding, right? So we just write it out, all of them. 24, 27, 1, 2, 3, 4, 5, 6, 7, and 8. So how many seats on the 8th row? That will be 33 seats, right? So that's how we look at it. Good? So we just identify each row, each term. That's how we find it. All right. So we just introduced the concepts of certain patterns by adding a number, same thing as subtracting number, is same thing as adding negative, or multiplying a number. Then, or when you multiply 1/5, it's same thing as divided by 5, right? So at the same time, those are sequences. We also did what? Series. Find the sum of the sequence, we call the series, right? Then we learn the notations, the sigma and the index, lower index and upper index. Then you write your general term behind the sigma symbol, then to represent your series. Okay? So we start from here, then we will do some more. That will be our section 12.1 for today.